Hello students, so this is about structures. Structures are given in your textbook, chapter 7 and in section 12. Structs are important in themselves and also because they're precursors to a topic that we will be doing in a week or so, which is classes. And classes are the foundations of object-oriented programming. So some of the things that you will learn in Structs may not make a whole bunch of sense, but then when you go into classes and objects, they'll be like, yes, I did want to have all of this information together in one place. So as you can see, I've got this file here, which looks a data file, which looks a lot like the movie database. And what Structs allows us to do is to create a programmer defined user type. What do I mean by this? Well, so far we've been working with integers and string and Boolean, and then also had the opportunity to create arrays of strings, array of Boolean, array of integers, and all of that stuff. And the kind of assignments that you did was create an array of strings, right? Read from the file and store this information in an array of string. What we'd like to do now is, instead of treating this whole thing as a string, as you can see, there is a number here, and then there's a string here, there's another string here, a number, an integer, and then a double. So inside this string, we have variables of different types. So far, what we've done is read this whole thing as a string and then tokenize it and convert string to integer and all of that stuff when we needed it. However, what we'd also like to do is we'd like to store this information not as a string, but as a record. And a record is one unit of information. And inside this unit of information, we have types, we have fields, which are of different types. So inside this single patient, this is a hospital patient record in which this is the patient ID, this is the patient name, and this is the insurance information. We also have a phone number information, and we have the outstanding bill. So as you can see, a single patient record consists of fields or units of information which can be of different types, and we would like to store one record of information. So far, we do not have the ability to do this in C++, but records is a feature that's available for us for the programmer to create a user-defined or a programmer-defined type, because only the programmer knows what application he or she is writing and what is that unit of information, what are the types of variables, or what are the types of information that's going to go into a single record. So I'm just going to hop over here and show you what a struct definition looks like. So here you can see this is not a variable declaration, but it's a declaration of a type. The name of the type is called record, and what's inside a single record should be an integer which corresponds to the patient name, a patient number, patient name, patient ID, a phone number, and a bill, exactly as we saw in the data file, right? So we use the data file to create a type, and the type is called record. We know it's a type because we've got struct here. And then what we can do is, in our main program, we can create an array of records. So, and as you can see here, we are declaring this data array to be of type record, which means each and every element of the data array is going to be one record, and each record is going to have all of these fields of information. So that's what a struct looks like, right? And now the question is, can I define a single record instead of an array of records? Yes, you can. So here you can see somewhere I have created a record R. I can even do something like let R be a record, and then so this record R is going to have all of these fields, and I can access the fields of that record by using the dot notation. So let's go back to the main program. And then what I can do is r dot patient. You see it pops up right here. Patient number, let's say, is equal to 10. And then r dot patient name is equal to, let's say, Sally Ho. And so on. So r dot phone number, let's say phone number is equal to 916-370-1111, right, for example. And then r dot, what was the last one? Bill could be equal to $1 million. Because it's a double. So here's how I can create a record, and I can actually assign values to this. What I'm doing in this example here is not creating a single record, but creating an array of records. And I will actually post this example in module number 6, so you will have access to this. What I'm doing is I have a data file which contains 1, 2, 3, 4 records, and therefore I have a constant which says size of that array is 4. I've got 3 files here. One is a header file, the main file, and the data file. And in the header file, I have declared the type, and I've used the type in main.cpp. Now, what I'm going to do in my main program is it's a menu-driven program right here, which first of all, it populates my array, and then it loops asking for what options do you want me to work on that database. Typically, if it's a hospital database, you might want to add a patient, you might want to remove a patient, right? You might want to check the bill, and so on. So let's run this program here. And as you can see, this says welcome to American Health. And then this has got, the first thing that it's going to do is read all the information from the file, populate that database, which consists of 4 records, and then display that right here. And now it's offering me the option to either find a patient, remove a patient, or whatever. Now I'd like to do this, display a total of bills. So let's do B. And it says the total outstanding bill for all patients is $742. It's a lot of money here. It's basically an addition of all the patient dues here. Now you might think I could do everything that I need to do by using an array of string. Why did I need to do array of records? Well, number one, records allow you the ability to store in a single record fields which have different types. So that's the first feature. The second feature is, let me show you the implementation. Let me show you the implementation of adding the bill, display data, not print banner. This also, by the way, has a lot of information on binary sort and binary search and bubble sort. So for those of you that are moving on, you will get a chance to see a lot of useful code here. This is the method that I was wanting to show you, display total bills. You see how the data array, which is the database of records, gets passed here and the size gets passed here. And what I'm able to do here is I'm simply able to access the bill field of that record and add that to my total. This would have been a very hard thing to do if my data array was a data array of string. I would need then every single time to be aware of what are the individual fields inside that string, convert them from string to double, keep track of, and do a lot more processing than you really need to do, because records offers you the opportunity to which is much more advanced than storing a string of information. It allows you the opportunity to have one record with all of the fields having different types, and you are able to access the field that is of interest to you. For example, here the field that's of interest to me is bill, so I can just go to bill and access that directly. So this is a very, very powerful feature, right? There is inside this code, I have included bubble sort and binary search. I would recommend you go through this because this will also help you when you're doing your future assignments. The other thing that I wanted to point here is you will see constructors. These are called constructors. Constructors are going to be a very vital part of classes and objects, and that's why I have included here. This just says that if you would like to create a record or declare a record and initialize it, then you can do so by using this particular constructor. A constructor constructs a user-defined data type with the information that's passed to it in the parameters. So here are the parameters, and what you're saying is that, can you create for me a record and use this information to initialize all the fields or to populate the fields? And I will show you here. You can actually say record, let's say S, and we can pass, let's say 100, and using this constructor, I pass the patient number, name, patient ID, and phone number and bill. So right here I can say, here is the patient number, here is the patient Derek Lang, and then here is the patient ID. I'm going to say VSP 1234, which is actually his insurance information. And then now I'm going to say the phone number is 916 985 9999, and then I'm going to say the bill is $12.56. So this way of creating a record was different from this way of creating the record. Here I gave a declaration saying a record R is of type, R is a variable of type record, and we know what a record type looks like because we have used struct to define it. And then, as you can see here, I've assigned the individual fields. This is a more powerful way to declare and construct a record by using a constructor that you should create in this manner, right? If you need to. This one is called the default constructor, and this is the regular constructor. And this is the default constructor. The default constructor does not assign anything. It just sets everything to the default values, which could be empty or 0. It's always a good idea to set everything to empty and 0 if you don't know what it's going to be, right? So this is how you can, I would encourage you to also go through this program to see how to, to access and to modify the fields of a record, put them inside an array, and all of the processing that you need to do in Module 6.